A warm welcome to one and all who are watching this video. I am Jenita Christy, Assistant Professor in the Department of Computer Science and Engineering, Bharat University. Today, we are going to see the topic Turing machine from formal languages and automata theory. So first, we'll see what is a Turing machine. A Turing machine consists of a tape. It's of infinite length on which we can read and write operation can be performed. The tape consists of infinite cells on which each cell either contains input symbol or a special symbol called blank. So it also contains of a head pointer which points to cell currently being read, and it can move in both directions. So this is what is the Turing machine. So the Turing machine consists of infinite length in which we can perform both the operations read and write, as well as this header which moves in both the directions, either to the right or to the left. So it consists of symbols, alphabets, as well as it also consists of blank that we represent it with B. So alphabets or the symbols we'll represent it with A. So we'll see what are all the tuples present in the Turing machine. So a Turing machine is expressed as 7 tuples Q, T, B, summation delta, Q naught, and F. We'll see one by one. Q is a finite set of states. T is the tape alphabet. B is the blank symbol. And then summation is the input symbol. And then delta is the transition function. So it means that it moves from one state to the other state depending upon the input. So depending upon its present state and present tape alphabet, it will move to a new state, change the tape symbol, and move header pointer to either left or to the right. So Q naught is the initial state. F is the set of final states. So this is what is the Turing machine is all about. It has 7 tuples to work in with. Next, so we're going to see some example. So let us construct a Turing machine for L, which has 0, N1, N, whereas N should be greater than or equal to 1. So we'll see those 7 tuples. The first is the Q here, the set of states, that is Q0, Q1, Q2, and Q3. And then the input, that the input here is the 0, 1, X, Y, and then B. So B represents the blank. So here Q0 is the initial state, like Q3 is the final state. And then summation. Summation, here the input alphabets, that is 0 and 1. So this is the transition function table which is given for us to do the problem. So here there are 4 states, Q0, Q1, Q2, and Q3, and the inputs here are 0, 1, X, Y, and B. So these are the transition function given. For example, if for Q0, if the current state is Q0 and if we receive the input as 0, then the transition state is going to be from Q0, it is going to move to state Q1, and then it will change the input as X, and then R. R means it is going to move to the right. Another example, for Q1 state, we have an input 1. So here in this case, if the current state is Q1 and if the input receives as 1, what will happen? The transition takes place from Q1 to Q2, and then it will change the input symbol from 1 to Y, and then it moves to the left because L is there, Q2, Y, L. So this is how the transition function works. So let us see how this Turing machine works for input string 0011. So initially head points to 0 because it is 0. So initially the head points to 0. So if we see the box, that is the tape, input tape. So what is that which is underlined and state Q0 as, see here, here 0 is underlined. That is what is the where the head points. So the head points to 0. That is mentioned with the underlined symbol. So B0-011B. So on the either sides, on both the sides of the input string, we have a blank B that is represented as B, and then inside that we have the input string 0011. So the head points to the first one, that is the 0. So now what we'll see what's going to happen. So now if we look at the transition table, yes, see here, if we look at the transition table, okay, now the initial state is the Q0. So Q0. And what is the input that we have received? The input that we have received is the 0. So if we see the tabular column, transition function, so Q0, and then the input is 0. So what will happen? The state is going to move to Q1. So from Q0, the state is going to get moved to Q1. And in the place of 0, we are going to write X. And the header is going to point towards the right. Move towards the right. Okay. So we'll see. Yes. So how do we write? Delta of Q0, 0. That is Q0 is the initial state. And the first input is 0. So if this is the case, so the output is going to be from Q0, there's going to be a transition Q1, and then from X0, it is going to change it to X, and then it moves to the right. So here it has changed to 0 has changed to X, and then it has moved to the right. So what is the next symbol? The next symbol is 0. So that is why it is underlined. So next, so the move will be delta Q0, 0 is equal to Q1, X, R. It means it will go to the state Q1, replace 0 by X, and head will move to right. So now what happens? If now the current state is Q1, what is the input? The input is 0. So what is going to be the next state? So we see the tabular column. So here the input is Q1, 0. The state is Q1 and the input is 0. So what is the next state? The next state is going to be again the same, that is Q1, and the input is going to be same 0, whereas the pointer is going to move to the right. So we'll see that. So still it is going to be Q1, and then 0, we are not changing it. It is same as that 0, and then the header moves to the right. So it moves to the right. So the right side, it is 1. So now 1 is underlined. Now the header is point towards the 1, which is underlined. Okay. So now the current state is Q1. What is the input? The input here is 1. So we'll see the tabular column. What is going to be the next state? So Q1, 1. So Q1 is the current state and the input it receives is 1. So the next state is going to be from Q1, it is going to be Q2. And it was going to replace 1 by Y. And the pointer moves towards the left because it is written as Q2YL. We have to do it like that. So now delta of Q1, 1 is equal to Q2YL. So 1 has been replaced by Y, and then the header move towards the left. So the move will be delta Q1, 1 is equal to Q2YL, which means it will move to Q2 state, and changing 1 to Y, it will move to left like this. Next, working on it in the same way again and again. Okay, now the state is this one. Okay, the input it receives this. Okay, and the next state is going to be this one, and replacing it like this. Okay, what we'll do, at one point, it will reach the state Q3. So at finally, it will be like this. Finally, it will look like this. B, that is black, and then X, Y, Y. So using this move, that is delta of Q3, B is equal to halt. Halt means it will be stopped or it will be accepted. So this finite state machine, it will be accepted. So this Turing machine, we have found out that finally for this input string 0011, finally it is this Turing machine is being accepted. So now in a non-deterministic Turing machine, there can be more than one possible move for a given state and tape symbol. So what is the difference between the ordinary deterministic Turing function and the non-deterministic Turing function? In deterministic Turing function, for a particular input, there is only one possible state. So at the time, there is only one state is possible, whereas in non-deterministic Turing machine, there can be many number of moves can be made for a given state, and for a given state and for a given tape symbol, there can be more number of moves are possible, whereas in deterministic, either to the right or to the left in a single time, at a time only it moves to the left or to the right. Okay, now non-deterministic Turing machine does not add any power. Every non-deterministic Turing machine can be converted into a deterministic Turing machine. So what we are doing, this non-deterministic Turing machine is being converted into a deterministic Turing machine. So in multi-tape Turing machine, there may be more than one tape corresponding header pointers. So, but it does not add any power to Turing machine. So, every multi-tape Turing machine can be converted into a single-tape Turing machine. So, every non-deterministic Turing machine will also be converted into a deterministic Turing machine, and every multi-tape Turing machine will also be converted into a single-tape Turing machine. So, all together, when it's all joined together, we may see it is moving in. There are many possible moves are there, but then whereas if we see it in a backward, it is like all non-deterministic Turing machine is being converted into deterministic Turing machine, and it works in that way. So now we'll see the second example of how it works. A single tape Turing machine M has two states Q0 and Q1, of which Q0 is the starting state. So here we have a Turing machine M. There are two states Q0 and Q1, of which Q0 is the starting state. So the tape alphabet, it is given M is 0, 1, B, and its input alphabet is 0, 1. The symbol B is the blank symbol, as we already know. It is used to indicate the end of an input string. So the transition function M is described in the following table in this way. The table is represented as illustrated below. So the question is, in the question itself, this transition function is given. So here we see the entry Q1, 1, R. It means that in row Q0 and column 1 signifies that M is in state Q0 and reads 1 on the current tape square. Then it writes 1 on the same tape square. So instead of 0, it writes 1. So it means like that. So the entry Q1, 1, R in row Q0 and column 1 signifies, it says that if M is in state Q0 and reads 1 on the current tape square, then it writes 1 on the same tape square, moves its tape head 1 position to the right and transition to state Q1. So from Q0, it moves to Q1, replaces 0 as 1, and it moves to the right. So this is what it does mean. So which of the following statement is true about M? So there are 4 options given. The option A is M does not halt on any string. Second option, M does not halt on any string in 0, 0 plus 1. M halts on all string ending in a 0. And the D option is M halts on all strings ending in a 1. So we'll see the solution and we'll see which option is the correct one. So let us see whether machine halts on string 1. So initially, state will be Q0. Head will point to 1. So here we have the entry as 1, 0, 1, B. So we have the initial state 0, and initially it is point towards 1. So on both the sides is blank and it is pointing towards 1. So using delta Q0 comma 1 is equal to, so it is like Q0 comma 1. So Q0 is the initial state. Now the first input is the 1. So we'll see the tabular column Q0 comma 1. So Q0 is the state, 1 is the input symbol. So what is the next state? Q1, and then input replaces 1 by 1, and then it moves to the right. So Q1, 1, comma R. So it will move to state Q1 and head will move to right. So what happened? So 1 will be same as that of 1, whereas only the header will be moved to right. Next. So next, now the state is Q1. What is the input? The input is B. So we'll see in the tabular column what is the state Q1 and if the input is B. So if the state is Q1 and if the input is B, so the next state is going to be Q0 and the input is B and it moves to the left. So Q0, comma B, comma L. So that is what is Q0, comma B, comma L. So what happens here? So B will be remain the same as B, whereas it will move to the left. So left means 1. So it is underlined. Now, it will run in the same way again and again and does not halt. If you look at there, it has come to 1, but it is not being halt. Whereas what is option D says, M halts on all string ending in a 1. So we have seen the inputs like 1. So whereas there is no halt. So it means that option D is incorrect. So option D is incorrect because it says M halts on all string ending in a 1. So we have checked that all string ending in a 1 does not halt. So obviously option D is not correct. So next we'll try for the next options. If you see the option 3 it says M halts on all string ending in a 0. So we'll see with this. So we're going to check whether M halts for a string ending in a 0. Okay, let us see whether machine halts on string 0. So initially state will be Q0, head will point to 1. So it will be like this, B, 0, B. Now, using delta of Q0, comma 0 is equal to, so initially the starting state is Q0 and the input is 0. So we see the tabular column. What is if the state is Q0 and the input is 0? So what is that? Q1, the transition from Q0 to Q1, and then if 0 means it will be replaced with 1 and it moves to the right. So this is what is the transition takes place. So it will move to state Q1 and head will move to right. So what happens? See here in the first input tape, it is written as B and then 0 has been replaced as 1 and then it moves to the right, that is to the B. Now the state is Q1 and the input is B. So we'll move to the tabular column and we'll see Q1B. So what happens if Q1B means Q0BL? So from Q1, it is going to move to Q0 and B is going to be remain the same, and it is going to, the header is going to move towards the left. So it is B1B. So everything remains the same. The head will move to the left. So this is what is the transition. This is how the transition takes place. So it will run in the same way again and again and does not halt. So for 0, if for all string ending with a 0 also, there is no halt takes place. So for, if from this we can say option 3 is also not correct. So option 4 is also not correct, because it says all the strings ending in 1 will halt. That is also false. Whereas option 3, it says all strings ending in 0 will halt. That is also false. So we'll check with the other two options, option 1 and option 2. Option 2, it says, there is option B, it says Turing machine does not halt for any string. So it says that it does not halt for any string, 0, 0 plus 1. So we'll see whether it will halt. So, but null string is a part of 0, 0. So null string is there. Null string is a part of this one. So, and Turing machine will halt for null string. Yes, for Turing machine will halt for null string. So, for example, see here, both the sides is blank. So, for if the starting itself is going to be blank, because it is a null string, the starting it's obviously it's going to be blank. So it'll obviously get halt. So this null string is a part of this one. So null string tape will be like this. So from this we say option B is also not correct, because option B, it says M does not halt on any string in 0, 0 plus 1. So it means that set of all strings. So there will be empty string, whereas empty string, there is nothing but a blank string, will obviously get halt, because it's going to be blank. So obviously it will get halt, whereas it says it will not be halt for all set of strings. So option B is also not correct. So from this we say option A is the correct one. So using delta Q0 comma B is equal to halt, Turing machine will halt. So as Turing machine is halting for null, this option is also incorrect. So option A is the correct one. So this is what is all about Turing machine. So we'll see this once again, all this about Turing machine. Turing machine. So a Turing machine consists of a tape of, it is of infinite length. It goes on which it reads and write operation can be takes place. So this read and write operation can take place on both the direction, either to the right or to the left. The tape consists of infinite cells on which each cell either contains input symbol or a special symbol called blank. So this is the diagram given. So it moves on and on, it goes on infinite length. So these are the inputs A1, A2 till AN. The B says it's a blank. And then we have a read-write header. So this read-write header we can move in both the directions. So there is two-way directions are there. So it's a read-write head. So there are 7 tuples in the Turing machine. Q, T, B, summation, delta, Q0, and F. So Q is the finite set of states, T is the tape alphabet, B is the blank symbol, summation is the input symbol, and then delta is the transition function, which means that the transition takes place from one state to the other state depending upon the input, and Q0 is the initial state, F is the final set of states. If any state of F is reached, the input string is accepted. If the state ends, if the state reaches F, it means that that input string is accepted. So accept state or final state F. Now here, for example, Q, we have the 4 states, that is Q0, Q1, Q2, and Q3. Q0 is the initial state. And then we have T. Here the input symbol are Q0, 1, X, Y, and then B is the represents the blank. And then input alphabet is 0, 1. And Q0 is the initial state. Q3 is the final state. So the tabular column given for the transition function. So it means that there are 4 states, Q0, Q1, Q2, and Q3. And the inputs are 0, 1, X, Y, and B. So here if Q1 means, so for the input, it is going to be Q1, 0, R. It means that there is no transition takes place. So transition within itself, Q1 to Q1, and then again 0. There is no replacement takes place, and then R, it moves to the right. See here, next for Q1, for Q2, the input symbol Y, it means that Q2, Y, L. It means that from Q2 to Q2, there is no transition, whereas here also for Y, there is no replacement. Only the header moves to the right and started reading the next symbol. So this is how the transition function says. So let us see how this Turing machine works for 0, 0, 1, 1. Initially, head points to 0 because we have a starting as 0. So initially head points to 0. So which is underlined and state is Q0. So here we have, so it is written in black color and underlined. So B0011B. So on both sides we have a blank and the input is 0011. The header now in the 0. So the move will be for Q0, 0. The move is going to be, we'll see how the move is going to be for Q0, 0. The move is going to be Q1XR. So Q1XR means it will go to state Q1, replace 0 by X, and head will move to right. So 0 has been replaced by X and head move to the right. So what is there in the right? 0, which is underlined. So now the current state is Q1 and the input symbol is 0. So what happens? Q1, 0. So Q1, 0, Q1, 0, R. Q1, 0, R. So there is no transition, whereas there is no replacement. Only the header moves to the right. So what happens? The header moves to the right. What is there at the right? 1. So it is underlined. Next. Now the state is Q1. What is the input? The input is 1. So we'll see Q1, 1. So Q1, 1 is Q2YL. So Q2YL. So here, if you see here, Q2YL. So Q2YL means transition from Q1 to Q2. 1 is being replaced by Y and the header moves to the left. So 1 has been replaced by Y and then header moves to the left. So it moves to the left, so it is in 0. So it goes on and on. So at one point, it will go to B. B means it will get halt. There's nothing, so it will get halt. So if it gets halt, if it is in a halt, so it means that it will be stopped and accepted. So this is how the Turing machine works. Whereas there is a difference between a Turing machine, a deterministic Turing machine, and a non-deterministic Turing machine. So in a deterministic Turing machine, at a time, there is only one move is possible. Whereas in a non-deterministic Turing machine, at the same time, we can have more than one possible moves for a given tape and a tape symbol. But a non-deterministic Turing function, it it works, how it works, it will be converted into a deterministic Turing function and it will work. So this is the example for a non-deterministic Turing function, how it works. The transition function is given and a question is being asked how the halt will take place. And there are 4 options given. So option 1, 2, 3, and 4. So we'll see the option 4, that is M halts on all strings ending in a 1. So if you see here, so all M halts on all strings ending in a 1. So if we have checked it with 1, but it doesn't halt, it doesn't go to B. So it doesn't halt. So what happens here? So for all 1, it says for M halt on all string ending in a 1. So for all string ending in a 1, it does not halt. So what happens? It doesn't halt. So it means that option D is wrong. So we'll check for the option 3. That is M halts on all strings ending in a 0. So if you see here, M 0, 1, 1. So here also for 0, the header doesn't halt. So what happens here? Here also option 3 is false. What is the option 2 says? M does not halt on any string. So in all set of strings, it says M does not halt. So it means that for empty string, it will get halt. So for if empty string, null string means there will be a blank. So if you see the blank, it will automatically get halt. So it says that for all set of strings, it will not get halt. So that is also incorrect. So option D, option B, option C, all are incorrect. So option A is going to be the correct one. So this is what is the Turing machine. I hope that you all understood the concept about Turing machine, and thank you for watching.